Hello students, in this video we are going to discuss 6.3 and 6.4 from electromagnetic induction. A long solenoid with 15 turns per centimeter has small loop of area 2 centimeter square placed inside the solenoid normal to its axis. If the current carried by the solenoid changes steadily from 2.0 ampere to 4.0 ampere in 0.1 second. What is the induced EMF in the loop while the current is changing? Here the given values are 15 turns per centimeter. That means small n is equal to 15 turns per centimeter. If you write this one in terms of SI, 1500 per meter, 1500 turns per meter, and area is equal to 2 centimeter square is given, that is 2 into 10 power minus 4 meter square, and the current is changing from 2 to 4 ampere in 0.1 second. That means di by dt is equal to 4 minus 2 divided by 0.1. That is equal to 2 by 0.1, that is 20 ampere per second. And what is the induced EMF? So the induced EMF, the magnitude of the induced EMF is equal to d phi by dt. That is equal to d by dt of flux is nothing but BA. That is A into d by dt of B. So the magnetic field due to solenoid will be mu naught Ni, this one. That is equal to mu naught N also constant. We can write mu naught N A into di by dt. By substituting the values, mu naught is 4 pi into 10 power minus 7, n value in terms of SI 1500, and di by dt is nothing but 20. If we simplify, its value is 7.5 into 10 power minus 6 volt. This is induced EMF. Coming to 6.4. A rectangular wire loop of sides 8 cm and 2 cm with a small cut is moving out of a region of uniform magnetic field of magnitude 0.3 Tesla, directed normal to the loop. What is the EMF developed across the cut if the velocity of the loop is 1 cm per second in the direction normal to the longer side, shorter side of the loop? For how long does the induced voltage last in each case? So, two subcases are there. One is longer side, one more thing is short side. In each subcase, we have to find out two terms. One is induced EMF and one more thing is how long, that means time taken. We'll discuss one by one. In the first case, before coming to this one, the given values B is equal to 0.3 Tesla and the velocity is 1 centimeter per second, that is also nothing but 0.01 meter per second, and length is equal to 8 centimeter, that is 0.08 meter, and B is equal to 2 centimeter, that is 0.02 meter. Coming to the first point, A here, longer side. Assume that this is the magnetic field into the plane, so we are taking a rectangle where some part it is cut, it is moving out from the magnetic field with velocity 1 centimeter per second. Now in this case we have to find out the induced EMF. So induced EMF is equal to BLV, that is nothing but motional EMF. So B is 0.3, L is 0.08 and V is 0.01. After simplification we will get 2.4 into 10 power minus 4 volt. And how long does the induced voltage last in each case? Until there is change of flux through this loop, the induced voltage will be. So the time duration can be calculated. T is equal to here B divided by V. That means how much distance that is traveling, 2 centimeter. B value is 2 centimeter. That is 0.02 divided by 0.01, 2 seconds. Coming to B. So the B is shorter side. That means the situation will be like this. This is the magnetic field into the plane, and it is moving out with velocity 1 centimeter per second. It is 8 centimeter and this part is nothing but 2 centimeter. So the induced EMF in this case E is equal to B, and the 2 centimeter acting as like the conductor B into V, that is 0.3 into 0.02 into 0.01. If we simplify, this value is 0.6 into 10 power minus 4 volt. That is induced EMF. Now the time for which the EMF lasts. T is equal to how much distance it has to travel? 8 centimeter. So L by V, 0.08 meter divided by 0.01, that is 8 seconds. So these are the solutions of 5.3 and 5.4. Thank you.